Good afternoon. All right, so I'm gonna keep it very, very short. You heard about a lot of tech all morning. Today, we're gonna see some of it in action with one of our largest Indian banks. All right, so this is gonna be in two parts. I'm gonna first talk a bit of banking technology, and second, how we've helped this bank build a modern data platform on AWS. So I can see a few sleepy faces post-lunch, which is normal. So just to get all of you going, what comes to mind when we talk of a bank? Anyone, anything? Anyone who works in a bank over here? Oh, awesome. Quite a few. All right, great. So what comes to mind when you think of banking? As an end user? Money, security, reluctance to change, okay? Data security, right? How about scale, right? Massive scale. Documents, n number of documents that you need to, lack of hyper-personalization. Right? Maybe even lack of transparency at times. Today we are in an age where even if you order a sandwich on a Swiggy or a Zomato, all the way from the time you place your order, you can see the driver who's on his way. He's picked up your parcel, he's reached your building, he's walking to your doorstep. All of that is very, very transparent. In a bank, not always, right? You, your friend, very similar profiles might apply for a credit card. One gets approved, one doesn't. You don't know the reasons, right? So there is a lot of things that need to be done. And if you look at some of the use cases, right, obviously this is not all. Things like credit decisioning, right? Things like document processing, optimizing a bank's portfolio, fraud detection, your call center analytics, better customer support, customer service. All these are use cases that banks were working on, but these used to be good to have other North Stars that you plan to reach to. Today with generative AI, I think it is almost a board mandate to get all this functioning on ground on day one, right? And as a result, what happens is, a lot of customers are getting enamored by this new technology, which is generative AI. And generative AI is great, but the magic really is under the proverbial iceberg, which is basically your data foundation, right? Because if you look at it, given enough time, each and every organization will have the access to the same LLMs and the same latest and greatest GPUs. Now, unless you focus on the data foundation, you will only end up building generic applications, which are honestly no different from the applications available over the internet, right? You need nuanced applications that understand your business, your data, and for that you need to build a data foundation grounds up. This means choosing the right storage, building data pipelines for different kinds of data. For example, a clickstream data pipeline looks very different to, say, a micro batch or an end-of-day batch that runs, right? And also purpose-built databases, analytics, solutions. Because again, with agentic, etc., you no longer can rely on transactional databases, right? You need vector stores. So how do you manage them? We heard about a new bucket that we launched with S3 to manage vector databases, but so on and so forth. So with that, if you look at platforms itself, right? This is easier said than done. Today, both your data warehouses as well as data lakes have evolved. If you look at data warehouses, they were typically built for transactional systems, for BI and reporting needs. But over time, with big data coming in, we saw these platforms evolve into architecture such as MPP, as well as columnar storage, etc. Similarly, data lakes. Their main purpose was to basically be able to store any data in any format reliably in a cost-effective manner. things like governance, things like metadata, things like data accessibility were all afterthoughts, right? So these platforms are evolving, but what's evolving even faster is the customer requirements. Today, customers want a single platform that they can use for transactions, that they can use for analytics, and also to build the latest and greatest generative AI applications, including agentic frameworks, right? What do customers want? They want compute and storage to truly be segregated, which means each layer can scale up or down based on requirements. They want a platform that will deliver end-to-end governance, which is built into the platform, right? They want open source technology, because gone are those days where customers are okay to be stuck into proprietary technology. Today, technology moves so fast, you want data to be in an open format so that the latest and greatest technology can be brought to data rather than the other way around. And also, customers want that same ACID compliance that you get in a data warehouse from their modern data platforms. And of course, all of this with the right price performance. So, what is the answer? The answer is basically a transactional data lake, which is built on a lakehouse architecture, which brings together both these best of both worlds, right? The structured format of a data warehouse, as well as the openness and the flexibility that you get in a data lake. And what really makes these transactional data lakes functional? It's the same open table formats that you heard of earlier today. So as AWS, we will continue to support the 3 common open table formats. And what these open table formats gives you is, one, you can do asset transactions like you would on a database. It allows you to do record level operations. It allows you to do indexing for better performance. It allows you to manage concurrency, which means multiple systems can read and write data simultaneously. It allows you to do schema evolution, which means your databases can evolve over time. You can add new columns, etc. And obviously, it gives you features such as time travel, so you can do point-in-time transactions, right? So all these things that used to be available only in databases or data warehouses are now available on modern data platforms. We obviously spoke about S3 tables earlier today. So again, this is built on, this is built on Apache Iceberg. It gives you 3 times better performance, 10 times higher transactions per second. If you ask why Iceberg, this is the reason, right? You have multiple people actively contributing and betting on this open table format, and which is the direction we are taking. That doesn't mean we will not support the rest, but this is the direction we see most companies going with as we move forward, right? So with that, I also understand this is a very oversimplified view. In a real world, this is probably how your data looks like. You might have a data warehouse for your operational data store. You might have data lakes where you're probably storing data from Clickstream, etc. And then I'm sure you have a whole bunch of SaaS applications where your data lives. So last December at our reInvent, Amazon launched something called the SageMaker Lakehouse. Now what this Lakehouse does, it's built on Iceberg Open APIs, and what this gives you is the ability to view all of this data, no matter where it is, through a combination of zero ETL and query federation, to view this data as one logical unit of data. What this means is you can bring in any query engine on top, a query engine of your choice. We would love it if it's an AWS query engine, but you can also bring in a third-party query engine, and you can query this data as one logical unit of data. Right? So this is where we see the world of analytics moving and helping complex customers like Indian banks. But with that, let's go into a journey. So Axis Bank, as you all know, is the third largest private sector bank in India. And the reason I like this example is this is probably a textbook method of how we see large enterprises adopt AWS and scale as they get deeper into it, right? So our journey with Axis Bank started during COVID, which was half a decade earlier, believe it or not. They started with the same thing, right? They needed a digital channel to onboard newer customers. They needed to start building newer digital journeys. So we helped them build their first account and obviously onboard newer applications such as video KYC, etc. Followed by that, they started obviously focusing on security, which is where we helped them build a landing zone, their first CI/CD pipelines, a mechanism to make sure all their PII data was encrypted, because security obviously is very, very important when it comes to a highly regulated industry like banking. As they got more and more familiar and more applications were onboarded, we looked into things like database monitoring, deploying infrastructure as a code. Later on, we started moving into things such as application modernization, and we picked up some really meaty applications like their CRM Next, right, which we tried to modernize on AWS. We also built and grounds up the entire corporate bank. So we took a digital view of what corporate banking should look like and built it grounds up on AWS. And 2 years ago, Axis Bank said, now that we have so much data already on AWS, why don't we build a modern data platform that can be used, right? But before that, it's important to understand the vision that they set out for, because obviously this was something that evolved over a period of time, right? This didn't happen overnight. So they wanted to globally benchmark themselves as a digital bank. They wanted to become a digital lending powerhouse. And obviously they wanted to acquire newer customers, etc. So they had two or three broad ideas, right? One, they wanted to be a leader when it comes to digital. And for that, they knew they had to build their data foundation if they had to take advantage of all the latest and greatest technologies that are available, right? Second, Bharat Banking. This is basically a tier 3, tier 4 areas where again data plays an important part, because a lot of these customers may not have CIBIL scores, etc. So you need to rely on third-party data when it comes to making lending decisions, collection decisions, etc. Right? Third, they embarked on a program called Sparsh, which was basically to empower their million-odd workforce to quickly be able to search information about products and in the end better serve their customers. And there was an IT initiative called Udan, where they wanted to obviously strengthen system resilience, but they also wanted to move from proprietary to open source technology, right? So with this, we had to basically build a modern data platform. And some of the factors, right? I think the use cases were very, very clear. They wanted to make use of the latest and greatest technology, which was generative AI, which came in 2 years ago, and agentic AI and SaaS, which is coming up now. Also, a lot of requirements for business was around real or near real-time data, right? For example, fraud. While it is good to detect a fraud and maybe correct it, what's even better is if you can prevent a fraud. And for that, you need to be able to execute real time, because once the fraud has happened, you've probably lost the trust of one customer and caused that customer a lot of heartache, right? So use cases were plenty. The problems were even more, right? One, in every large organization, right, you have owners for each and every core system. And these owners, their job is to make sure these systems run, and that's it. And these owners will not let you build CDC pipelines to pull data from their databases. For example, core banking. No one will ever let you pull data out of core banking because it impacts performance, right? So what happened was every time people needed data, they had to scramble within the organization to see what data I could use. And in turn, they would run into issues around data quality, data freshness, etc., right? And there was no real owner for data. Right, you had owners for source systems who didn't really want to share data because their main imperative was to make sure the system is performant and running. And then there were these use cases building up which needed data, but there were no real owners of data. And every time someone wanted to do something with data, they would take a slice from here and there. So you end up with multiple copies of data, and over a period of time, you don't know what data is what. For example, just think of a sales table or sales data. You'll probably have hundreds and hundreds of tables within your organization, and you don't know which one to pick, right? Data quality issues, and obviously as scale grows, right, you have issues around availability, scalability, pipelines breaking, issues during month ends where you need to run a bunch of reports, issues when you have to run reports for the regulator, which is also increasing day and day. So there were n number of issues. So when we got to solve, what we recommended was we start moving away from operational data stores into domain-based data stores, right? So we identified the main sources for data, which were things like your credit card systems, your core banking, obviously, your LMS, which has all your lending data, as well as your payment systems. Then we started carving out the domains. Customer was one domain, your transactions, products, payments, right? And then we actually built teams who would be virtual teams comprising of both data engineers as well as owners of the source application, which would be the primary feeders for these data products. And we built these teams whose job was to own this entire pipeline, right? And the way we built it was following the medallion architecture, which means you ingest data from various sources based on what your domain requires, and you keep it as is in the bronze layer. This is basically your raw data comes in as is. The reason we keep it like this is for things like compliance, etc. You need to have your raw data, right? After that, we run DQ rules, etc. And we cleanse the data, and this becomes your silver layer, which is your cleansed data. This is great for things like analytics, etc., but probably not great for end business use, right? End business users want aggregated data, thoroughly cleaned, ready for consumption. It could be through APIs, it could be through batch ingestion, however. So that is basically your gold layer, which is your finished data product. And now this entire pipeline is managed by this virtual team. And today, obviously, we built a governance layer on top, which takes care of everything. If a user or a business comes and they want to search for a particular kind of data, you can do a search. You know exactly what data I need or what data products I need. You subscribe to them. There is an approval process based on your permissions and things like that. You approve either the entire data set or part of the data set, and then the consumer can start using it. So that entire workflow is built today, and it again powers a whole bunch of use cases. For example, statements. The statement that you get at the end of the month, it seems like a very, very easy use case, right? You have your transactions, your debits and credits that happen in your account, and end of the month, you have a snapshot. But if you really look at it, one is obviously all your transactions that you do. Second, you have your credit cards that you take from banks. You need to ingest that data. You have loyalty points and things like that. That's another system. You need to ingest that data. There are billing systems that probably charge you for monthly minimum balance not met or certain services that you use. So those calculations need to be done. Then you probably also do investments with a bank. So all that data needs to be ingested. So all of these use cases, which used to be standalone applications, can now be built as modern processes which just consume data from these data products. Could be real time, could be batch. And this has enabled a whole bunch of applications, downstream applications that are being built, right? This is what the architecture looks like under the hood. So we obviously have a streaming service, which is MSK, through which we stream all the data. We use EMR to do the processing at different levels. And they use, again, a combination of Hoodie as well as Iceberg. They started with Hoodie because that was the preferred choice 2 years back when it came to CDC. Obviously, things have evolved now. And again, when it comes to consumption, you have an option of both real-time data processing as well as micro batches, which are every 15 minutes. So that is where they are today. Going forward, we are already working with them to build AI agents when it comes to data engineering. So things like generating new code, doing data classification, right, anomaly detection. We are building agents along with them to do all of these things. And obviously the data products that have been built already, we are basically leveraging technologies like MCP server and vector stores so that this data can easily be accessed by downstream generative AI applications. So again, this was a quick story of all the technologies that you heard in action in India in a very, very complex environment like a bank. And with that, I will end with the same line that Biswa said in the morning. Data is the genesis for all innovation, and we hope together we can build a data-driven future with all of y'all. And with that, I know my time is up, so thank you, and hope y'all have a nice day.